asking when does its when does its rotational velocity change, right? So at the
Yeah.
very beginning, it's not rotating. We can all agree on that. And then it says that it is pushed with a constant horizontal force directed towards the sphere's center of mass, right here. So while it's being pushed towards the center of mass, is it going to start rotating, or is it going to stay not rotating?
It's gonna stay not rotating.
Correct. It's going to stay not rotating. So its sphere's angular momentum doesn't change. Then from B to C, there are no forces acting on it. So is it going to stay not rotating, or is it going to start rotating?
Stay not rotating.
Yep. And then from C to D, there's a frictional force, because at the very beginning of the problem, it said that C to D was the rough patch. So then it's going to have the ball will be here, and it's going to have a frictional force pushing it this way, but more specifically, it's going to be pushing it at the bottom. So that's going to apply a torque. And so from C to D, it will start rotating. And then from D to E, it
Uh,
will keep its angular velocity that it had once it left D.
okay. So it's accelerating from A to B, right?
It is accelerating from A to B, but its angular velocity is still 0.
Okay. So what I got mixed up was because because angular momentum because MVR. I thought that because its linear velocity is increasing than angular momentum. So what's the like faulty logic in that?
So MVR, and this is again goes back to understanding equations. MVR is a very specific equation. MVR is for comparing linear velocity or linear momentum, sorry, to angular momentum. And first of all, there's no collision happening here, so that equation you just immediately tell you that equation isn't applicable. But second of all, it has to be used from a point that is a distance greater than 0 from the point of rotation. And there is no point on here on this diagram that you could even use. If you used, for example, the plunger for some reason, um, well, that would have 0 angular momentum the entire time because it's never rotating relative to the plunger, and everywhere else there's no real point you could use. So MVR is only used for collisions that cause rotation.
So okay, I'm not sure if I understand when to use MVR then. So I know that. So I should use I should have used m what was it angular velocity, right?
Yeah, well, I mean, you really should just recognize that angular momentum would be equal to rotational inertia times
Oh wait, no, angular rotational inertia. Yeah.
yeah, rotational inertia times angular acceleration. And you should know that rotational inertia is based on the mass and shape of the object, and that isn't changing. So the only thing that would change its angular momentum would be its rotational acceleration.
Pixels. Better.
There we go.
As for MVR, like it's basically saying, imagine you had like a bar and then a ball and it's moving. And right when it passes the bar, and the bar is like on a hinge here, right when it passes the bar, the ball sticks to the hinge. Right when the ball passes the ball sticks to the bar and starts rotating. Right. So that's an example of when you can use MVR because that you can translate its linear momentum to rotational momentum because as soon as it sticks here, then it will start rotating. The reason why that works is because your point of rotation is over here, which is not at the same place as the center of mass of the ball, right? So R is non-zero. And anywhere over here, either you could pick like the center of the plunger, which makes no sense, or you could pick the center of the ball, in which case R would be 0 and MVR then equals 0. So MVR doesn't work at any point in here.
Do you think we'll actually have to use MVR on the exam, like very much? Then
Not very much. I mean, you might need to use it, yeah, but I don't recall using it on our exam, so.
okay, yeah, I'm not sure if I still understand when to use it, but I can just hope that I really don't have to use it.
Yeah, it's not very common. And again, in this case, all you needed to recognize, well, the only way that angular momentum could change in this case is if the ball changed its angular velocity, because it's not like its mass is suddenly changing. So that's all you needed to know. And then once you knew that, it was really asking when did it change its angular velocity, then you go from there.
Okay, I think I get it.
Okay, cool. Anyone else have any questions about that, or just anything? Okay, So back to what I was saying earlier, what do you guys think is going to be most helpful right now? Do you guys want to continue going over the multiple choice questions from the mock exam? Do you guys want to do Albert, or do you guys just want to talk about topics or anything else? What do you guys think is going to be most helpful right now?
We were assigned in physics these FRQs. Could we like go over those, maybe?
If you have them and they're not related to electricity, then sure.
Is there a way to should I screen share or what? Can like one of the people that have I don't
Is
know,
it not like a
phones or
document?
whatever, like do it?
It's on AP Classroom.
Oh, it's gonna be Classroom. Yeah, we don't have
Yeah, but
access to
he
that.
Oh wait, I
assigned us.
forgot about that.
I can
Nice.
screen share if you want.
Yeah.
Or just take a screenshot and put it in homework help.
That's true. I'll send it. I'm putting in general. That's the actual problem, and then
Alright, thank you, Concept Board, for not uploading the image.
that's great.
Did Concept Board crash?
I don't know.
Hmm.
That,
Well,
okay,
that didn't work.
that ain't it. That ain't it, Chief. That is.
I'll take the bottom text as a different screenshot, probably, or
It was just ABC, right?
um, yeah.
Okay. I've not done one of these problems in a while, so I may be a bit Rusty, but we're gonna do it anyway. All right, so basically, each of these blocks has a weight force, right? Actually, do you want me to go through? Or do you want to, you guys talk about it?
No, we
But
did.
you should maybe attempt it first.
Yeah, you can do that.
Okay.
While everybody's like trying to do it, could you explain center of mass again? Because at like number C, it asks whether or not the center of mass, like the acceleration of the center of mass, would change or not, and I don't really understand that like topic.
It's the center of mass is like the average.
Did he just cut off?
Yeah, no, I'm trying to figure out how to speak words. Um, it's like
Brain. Oh, sorry.
it's like the center of mass is like the. I'm trying to think of the right way to explain, but I know I don't have it. Nathan, you have any? You have a better idea than?
I mean, like there's two ways to think about it, right? Like equation wise, it is the average position of mass, right? So you take you boil it down to point particles, pick any position on, in 3D space or 2D space, and every other point would be equal to its mass times its distance. Add those all together, divide by the number of distances, or by the total distance. The other way to think about it is, if it's a closed system and no net force acts on the system, then the center of mass doesn't change. So like if you imagine, we were two people in space, right? And there was no external forces and only like we pushed on each other, right? Or pulled on each other, either way. We would both end up maybe with different velocities, but if I pushed on you, you're not just going to push away. I'm also going to push away from you as well. And so overall our center of mass doesn't change. It's in the same position because the only forces were created from us. There's no external forces. Now, if something else were to pull on or push on us, then our center of mass would change. And really, AP is only going to look at it from that second perspective. Technically, they could ask you about the first one, like mathematically, where's the center of mass? I just have never seen it, ever, so I would really
Yeah.
doubt it.
Also, it's the point of like if you put something on your finger on the center of if the center of mass on it with your finger, then it won't tip over.
That's true.
Yeah, if that helps to think about it. And if anything, they didn't really need to say acceleration of the center of mass. They could have said, well, I guess they could have said average acceleration of the system. Well, couldn't they just said acceleration of the system?
Yeah, it was technically the same. They just specified center of mass because they always like being clear.
Yeah. Yeah.
Okay, so we said we can talk about it together. So do you guys have any ideas as to at least where to start with this problem? Or a better way to ask it, what should you always do? I don't know if your teacher has hit this as hard as Mr. Mills did, but what should you always do when looking at a problem involving pulleys, or really any sort of dynamics problem?
Label forces.
I
Free
mean,
body diagrams?
yes.
Yeah, I was going for free body diagram, but yeah. So let's look at the 3M block. What forces are we going to see on the 3M block?
Tension, weight.
Okay, so the weight force over here and the tension force over here. And what will the weight force be equal to?
3mg.
3mg. And then what will the tension force experienced by this block be? I kind of wrote that a bit low, but
mg.
yes, mg. I'm actually not going to label it tension because it's technically not, but because the tension in the string is uniform, but the block only experiences some of it, blah, 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 blah. Technicalities.
Why is it mg?
Because that is the mass of this block. Or that is the weight force experienced by this block, rather. And the pulley, as it says in the question, has negligible mass and friction. So the pulley, all that the pulley does in this scenario is redirect force. It doesn't act on the system at all. So it just takes this force that's being experienced by M, the weight force, and puts it on the top of the 3M block and pulls it up.
Hmm.
Okay, so that's our free body diagram.
Wait, I had a question.
Yep.
Um, for the other mass though, wouldn't the tension for that one be 3 mg?
Correct. The upward force would be 3 mg. That's why I took out the label of tension, because this force we're labeling here is not tension.
Yeah, because I thought the tension has to be the same, since there's no inertia. But then uh, it's not, which is but
Right. It isn't. Well, the tension is the same. That's why I took out this labeling here. So here's the thing: if you knew the acceleration in advance, what you could do is say, the net force of this block is equal to, mg minus the tension, and the net force in this block is equal to 3 mg minus the tension, and then combine those two equations and solve for t. So the tension is different than both of the forces that these block experiences upward. The reason is because not only is the tension force, existing, but the entire string is moving. So the forces that they actually experience is not equal to the tension and is different.
oh, all right, got it.
Now we can't solve for tension, at least not now, because we don't have the acceleration.
Also, Nathan, your screen's getting
I
pixely.
I
I
used
don't know what to do about that.
energy for this.
I mean, that looks like it's good.
Yo, I used energy for this.
How?
Let me check. I did it in class today. Let me check what I said.
Does it mean I guess? No, you won't be able to do that.
I said because it would be like the change in distance, right?
I mean, okay, you could do that. You could do that for A.
Yeah, for A.
I
did for.
think.
I said it was Here, let me do.
I mean, I guess you could
I
also find the
am
work
not
done.
entirely sure you could. I mean,
You'd
That's
have.
what I said it was.
You'd have to put in.
did he show you the answer yet, or did you guys just do it?
They'll do tomorrow, so no.
Okay. I mean, so like as long as you took into account the other block, I think it might work. But if all you did was 3 mgh and then mv squared, or 1/2 mv squared,
Oh yeah, no, that
you,
yeah, no,
you,
that
you,
that
you
wouldn't work.
forgot about the other block. That would not work.
That would work because as well as you decreasing because you accounted for the increase in mgh, but you didn't
Yeah,
account for the
I
increase in
essentially made it.
but you didn't
Essentially, just
account for
made the
kinetic
change in.
energy because you have to also account for kinetic energy as well.
I did. I said it was initial mgh equals like 1/2 mv squared plus like final mgh, and then the height difference would be d. So I just subtracted like one from the other, and then it would just end up being like mgd equals 1/2 mv squared, and then I solved for v.
Oh, where's your m go?
And where you have two blocks here and they're moving in opposite directions.
Yeah.
M is there.
And what you sent me? I see your mgd. I see uh your gravitational potential, but where's the 1/2 mv squared part of your?
It's because I solved for v, so the 1/2 went to the other side and became a 2, and then the squared became a square root.
Okay, no, that one worked. That don't work then. No.
Alright.
You need to split the blocks up and account for their kinetic and potential energies separately. Because the kinetic energy of one block will be opposed by the other kinetic energy of the other block. You could do it, but it'd be a pain in the ass.
Okay, so I like you could do energy. Like energy is not and especially since part B is about the work, you could do energy. You just got to be extremely careful about how you do energy.
Yeah, because you need to do because one side is going to have increasing kinetic energy, decreasing
They're both gonna have increasing kinetic energy.
Yeah,
One's
they're
gonna
both
have
gonna have
increasing
increasing
potential.
energy,
The
but one
other's
of
gonna
them's
have
gonna be in the
decreasing
opposite.
potential.
One's gonna be in the opposite direction though. Wouldn't it? Wouldn't they have to account for that here?
Kinetic energy is positive always.
Huh.
So that's the issue, is that they both have increasing kinetic, but one has increasing potential and the other has decreasing potential.
Yeah. So you need to do 3 mgh minus 1 mgh equals 1/2 4 mv squared. Right? Are that right in my
Yeah.
head?
Yeah, that should work. But anyway, we already started with this, and I'm assuming this is what most people did, or did everyone else do it energy? I mean, we should go with whatever most people did, which I'm not sure what it is, but what did you guys do? Did you guys start off with labeling forces in this way?
Yeah.
I was thinking about using like F equals MA.
Which is what this boils down to, yeah. Okay, so if this is our free body diagram of the 3M block, how can we get what would the next step be to approaching the velocity v?
Do we use kinematics?
Not yet.
Not yet.
Not yet.
Oh, okay.
So
Can I
all
ask
we
a
have
question?
all we have is our free body diagram that we just drew, right? And we need to, what is the next step towards getting the velocity of the 3M block?
Finding the acceleration.
Okay. What is the step directly before that?
Um,
If we have a free body diagram, what do you need in order to get net acceleration? Or what is net acceleration proportional to? What the step I'm thinking of is probably one you've all thought of and you all are thinking of. I'm just going like baby steps here.
like combining the forces.
Yeah, net force.
Yeah.
Okay.
Or getting your net force. Yep.
Yeah.
So that's going to be, if we're gonna say down is positive, because it's just gonna make the problem easier, right? So I'll just draw this arrow saying down is positive. Then what would be an expression for our net force?
Three mg minus mg.
Yep. And that boils down to 2 mg. I'm really good at writing FNet, clearly.
Sorry, my computer died, man.
Okay, all we did was write FNet. Okay, so now that we have FNet, how can we...
Wait, that says
Um,
FNet?
Yeah, you know what, Elliot? I don't want to hear it.
You live with
FNet.
me. His handwriting's still
Yeah, I
better
know.
than
His is
mine.
worse than yours. I didn't even know that was possible.
Nathan's handwriting is not worse than mine. I
You
don't
know,
know what Nathan
round
is doing.
round of applause. That's I never thought I could see.
He's also
worse
okay. He's
handwriting.
also writing with a mouse.
I drew with a mouse for 4 years.
You're writing with a mouse? I thought you had some
I wasn't-
blackboard or
I
something.
I did. Right now, I'm not using it because that's a lot of work.
Oh.
It's effort. And anything that can reduce effort is obviously the best solution.
Wait, yo, I'm sorry. My computer died, so it like cut me off in the middle of your explanation. But that's Joe.
All we did was write FNet. Is equal
I-
to 3mg minus mg, which is 2mg. Because we define downward as positive. Okay. So, now that we have FNet, what is the next thing? You guys were right on all of the steps before, so.
Divide by the mass to get the acceleration. Right?
Yep.
Yep. So, remember we have F is equal to A, and then that means that A is equal to F over M. Imagine that I can write. Sure, good enough. So A then is equal to 2mg over what?
4m.
Yes. Why is it 4m?
Because you're combining the masses.
Correct. Yep. The net force that is acting here is acting on everything, the whole system.
Okay.
And so that leaves us with the m's cancel out, and that means A is equal to 1/2 g. Okay. So then so that's gets us our acceleration. What is going to be the next step towards getting the velocity?
Use the kinematics equation to find the velocity.
Yep. And what kinematics equation? Let me pull up the formula sheet. What kinematics equation can we use?
Could we use v squared equals velocity initial plus 2a, and then like the second? Oh, I know, the third one.
Yes, this third one. And the reason why this third one would be a good idea is because it has displacement, which is the one thing we know here. It tells us d.
Wait, why would it be 4m again? Is it because you're finding for the whole system?
Yep.
Correct.
'Cause I thought
Yes.
it was just for that one block.
It doesn't matter though. The system is still connected with the string. So also keep
Oh,
in
so
mind that
four-
the acceleration of the 3m block will inherently be the acceleration of the m block. They will always be the same, just in opposite
Oh, that's true.
directions.
Alright, thank you.
So yeah, so we'll use the second equation, which is v squared is equal to initial velocity squared, which is 0, so we're not going to write it, is equal to 2 times a, which is 1/2 g, and then times change in x, which is going to be d. And that basically means v squared is equal to just gd. And then v is equal to the square root of gd.
That is hella confusing. I would have never thought that.
Okay, so does everyone understand A? At least the way that we did it here. We might go back and do energy, if anyone wants that later. But
Yes.
Yeah, I get it.
okay. So the next one is determine the work done by the string on the two-block system as each block moves the distance d. So what is our equations for work?
FD.
4 times distance.
Yep. And remember that we're always going to say work is equal to force parallel to distance times distance. So what do we also know about the tension force in a string?
It's equal for both of them.
Mm-hmm. And we know that this block is going to move up a distance d. And this block is going to move down a distance d. Right?
Yeah.
So the work on this side, I know I'm just kind of spelling this out, but this one is not that hard, is going to be the distance here times whatever the tension is in the upwards direction. And this one over here is going to be the distance times whatever the force is, which is the same, the downwards direction. So they're going to be same magnitudes, but opposite signs. So what is going to be the net work done by the string on the two-block system?
0.
0, correct. The string does no work on the system. You can also think about that just logically. Like, is the string really the thing that's moving the system or causing it to accelerate? No. What is actually causing the system to accelerate?
The
Net
weight.
force.
Or just gravity would be the most appropriate answer. The gravitational force.
I also thought it might be 0 just because, like when we set up the free body diagrams and stuff, we didn't actually factor in tension, so it didn't really matter.
Yeah, that's another way you can think about it. There are many ways to think about it. You can do an equation, or you can just do it logically. The string isn't causing the thing to accelerate. But, yeah. So does everyone understand why B is the way that it is?
I think so.
So it's just because the tension force doesn't cause the acceleration, right? Doesn't cause the
Correct.
blocks to go.
Yeah.
Okay.
So the work is done by gravity.
The work is done by gravity. Yep. You have to think sort of about what is causing the energy to go in the system. Because obviously at the beginning they're not moving. At the end they are moving with a certain velocity equal to square root GD. So something is causing the velocity. And it is the string the thing causing the velocity change here. And it's not. They're just holding up the blocks. What's causing the velocity change here is the force of gravity. Hypothetically, if you were then to expand the system and say, look, the Earth is included in the system, well, then there's still no work being done because now you're including the fact that the Earth is technically moving slightly closer to the blocks by a very marginal amount. And that's whole complicated stuff that we've talked about before. But yeah, I mean, you can, or if you can't, if you're not able to think about it that way, the string isn't causing the acceleration, then you can always pull out your equations like I did here, look at the fact that the force is the same, distance are not opposite directions, so it has to be same magnitude, opposite sign, and that cancels out. Okay. So the last part is the acceleration of the center of mass of the block string pulley has a magnitude a com. I'm confused where com comes from, but all right. Briefly explain in terms of any external forces acting on the system why a com is less than g.
Pretty sure com is just.
Com stands for center of mass, right?
Yeah, I mean it does, but I don't think they used that notation when we did it.
I don't think so. I mean, also it's irrelevant. You don't need to say center of mass. You can just say like the net acceleration.
Yeah. All right. I mean, it doesn't really matter. So, what were your guys' answers for C?
I said like because the gravitational force, like if the objects were literally just in free fall, then the acceleration would be gravity, but they have like tensions and whatnot working against them, so they have other things there which are going to slow down the acceleration.
Okay, so you're good. You're good up until you say tension and other things.
Right, so they're just going to be forces in the opposite direction, opposite to the weight force. So while like the gravity, like the acceleration of the weight force, the acceleration from gravity is going to pull in one direction, there are going to be forces that counteract that in the other direction, I guess. So the acceleration of the center of mass is going to be different.
I would have said that it's because like one of the weight forces is like positive and one of the weight forces is negative. If they were just both going in the same direction, then like if they were both going positive direction, which is down, then it'd be the same, right?
Yeah, you're both on the right track. In concept. First of all, I want to say something about the first answer there. It says in terms of any external forces. Is tension an external force in this system?
No.
No. So if your answer includes tension, don't include tension in your answer because it says in terms of any external forces. I get 100% what you're saying. What you're saying is not wrong. What you're saying is correct. However, you need to sort of phrase it in a way that makes sense to get the points for part C. The general idea that I hear you're getting at is that you have one gravitational force working to accelerate the system and one gravitational force that is working to decelerate the system, and so the two gravitational forces acting on the system are opposing each other. Is that sort of what you're saying?
Yeah.
Yeah. So if you said it that way, and specified 3M block as having a higher force, the M block has a force that is opposing the acceleration produced on the 3M block, then yeah, that would explain in terms of external forces why the total acceleration is less than g. Another way to explain it, which is how I would personally have explained it, is that the work done by gravity on the 3M block is positive, whereas the work done on the M block is negative. So you have two gravitational forces that are doing opposite energy on the system, and so they're opposing each other.
Can you repeat your explanation?
The work done, so remember we said over here is first force parallel to distance, right? The force of gravity on both objects is going downward. And the 3M block is moving downward, whereas the M block is moving upward, right?
Yeah.
So the work done by gravity on the 3m block is positive, and the work done on the m block is negative. So the total work done on the system is less than if there was only one gravitational force acting on either block. So the two gravitational forces have to be opposing each other. That's what I would have said. That's not necessarily what you had to have said to get the answer. The first thing that you guys were sort of getting at, which is that just in general, the two forces are opposing each other in terms of acceleration, would have been fine, as long as you said that explicitly and didn't say tension and other things.
But how does that make it less than G? Why wouldn't it be 0? Is it just because the masses are different? Like they have different masses for each
Correct.
block?
Correct.
Oh.
Yep. Imagine if this one was 3m. If they were both 3m, the acceleration would be exactly 0. For the same reason, though, because the two gravitational forces are opposing each other. The question only asks why is it less than g. So you didn't need to specify between 0 and just less than g.
Wait, I'm so confused. Why is it less than G?
So imagine if you just had the one block, 3m block, or for that matter, the 1m block, right? Just imagine you just have one of them.
Oh wait, it's because it's pulling against each other, right?
Yes, they're
So
pulling.
it's kind of like it's kind of like what we did at the top back when we were finding velocity. How like you had to find like 2m.
Yeah.
Right. Okay. Right. Okay. So that makes more sense. I'm sorry. It took me a minute to get there.
You're good. Okay, so does anyone have any questions about these three parts here? Okay. Who was the person who said about energy initially? Because I was just doing
Me.
it on paper and you get the same answer. So I'm just going to briefly show you how you would do that correctly. And maybe this is how you did it. You just, you sent your answer to Alan, so I didn't even see it. But, so what you're looking at here is, the fact that this block here moves upward and this block here moves downward, right? So the 3M block gaining potential energy or losing potential energy?
It is gaining potential energy.
The 3M block?
Oh, sorry, kinetic. It's gaining kinetic. It's losing potential.
Losing potential, right? So the change in potential energy, and then also this M block, is that M block gaining potential energy or losing potential energy?
It's gaining potential.
Right. So then that, and they both move a distance d just in opposite directions. So the change in potential energy is going to be equal to mgd minus 3mgd, because this block is gaining potential, and this one is losing potential. Does that make sense so far?
All right. Yeah.
So then overall, the change in potential is equal to negative 4mgd. And the change...
Wouldn't it be negative 2?
Or negative 2. My bad. Negative 2. And then on the other side, you can say that is equal to the change in kinetic energy, which would be 1/2 4m, because we're talking about the sum of the masses and they all have the same acceleration. The kinetic energy of the whole system, so 4mv squared. And what you may notice is these numbers are the same as the numbers we have over here.
Wait, why do you set them equal?
Because you're saying that the potential energy that was lost by the time it reaches D has all become kinetic energy.
Oh.
Remember,
Okay.
it's a closed system, so the change in potential energy is equal to the change in kinetic energy.
Alright, so we're not factoring in like the Earth or anything like that.
You wouldn't have to, no, because it's a closed system here.
Alright, so then.
And then you literally just solve for v squared, and you would end up getting the same answer.
Oh, alright. Also, so that means for energy, you have to put the energies of both the objects in the system, because I just did it for one of them.
You have to do both. Yep, because they're connected by a string. You can't just pretend the other doesn't exist.
Okay, so when you have an energy problem and you have multiple objects in the system, you have to account for all the energies of all the objects in the system.
Most likely, yes, unless this. I mean, I don't want to give a broad answer of yes every
Right,
single
right,
time because the
right.
problem could, say something in particular that makes that not valid. However, most of the time, that is a true statement that you have to account for everything.
All right, thank you.
Okay. Is there another FRQ you guys want to go over, or anything else here?
Did you guys already go over the liquid one? I don't know. I don't know if Florence has that.
The
available.
crazy oil one, Alan.
The
Oh
oil
yeah,
one.
I was doing that one with Ellie. What the hell is that question?
All right,
Look,
now
look,
I want to see it. Now I want to see it. Come on.
Look, okay.
It's
My problem was that like, I thought I was really good at least like decent at FAQs. You know, like the ones we did in class, and then the ones we did like in your practice tests and like during tutoring. Were all good. Florence
don't feel bad about it. That question is an enigma.
Florence just assigns this FRQ, and I'm like, hold on, like the first FRQ question was fine, right? It was literally just the basic, good old like test for frictional torque and angular momentum. It was fine, but then the second one was like, it was the weirdest. It was literally the weirdest FRQ I've
Yeah,
ever
so,
seen.
no, so send it in general or something, so Nathan can look
What are
at
you
it.
talking about?
The
I
the
don't-
frickin' oil, the ball falling through oil question.
Was this
Oh,
one?
ew! That's
was this one-
disgusting.
Was
Okay, was
gross.
this one what? Was this one on?
That was like the
It-
nastiest
It
question
was
I've
on
ever
AP
seen.
It was
I
on
think
AP
it's
Classroom. I don't know
lost.
why it was on AP Classroom because that is one of
I
the
mean,
worst
at the end of
FAQs.
the day, there's always the outliers, right? There was that one FRQ on the IB exam that like actually melted my brain, um, because it was so retarded.
Oh, also, I mean, okay, I don't know if we can actually access the FRQ. I mean, I'll check, but it might have been closed because I don't know. It was like a secure exam or something.
I'll
No,
see
it
if I
wasn't
can look it up
secure.
too.
No, the
That was
multiple
an
choice was
MCQ.
secure, but the
Okay,
FRQs weren't.
Excellent. Also, can we also go over the other one on that because like I get the it was like I don't know, it was
Pumpkin.
like if an arrow hits a pumpkin hanging on a string, if it embeds itself in the pumpkin versus going through the pumpkin versus bouncing off the pumpkin, which one
Which
would
one
be
go
like
high?
the highest angle?
Yeah, could you
swing?
go over that one?
That one was also weird. So yeah, I'll see if I can pull them up. Because both
I
of
feel
those
so.
really
Florence
different.
said that it was such an easy question, and when I got it wrong, I felt
No, he
so
said
bad
what was
about
just an
No,
easy
no,
question?
no, he
Which
said-
was
he
easy
said
question?
that when he
Pumpkin.
figured out how to do it, it seemed like it was like conceptually easy, but I don't know. It didn't really seem that like conceptually easy after he explained it.
This is the oil question or a different one?
No, I was talking about the pumpkin one.
Pumpkin.
Okay.
Yeah, I'm talking about a different one. The oil one is also really weird.
The oil one, God. I want you
I-
to see this one, Nathan, because I looked at this problem and was like, and I had to do a double take, like, huh?
Yeah.
What are they
I mean,
asking me?
speaking of dumb FRQs, by the way, I need you to look at the one from the IB exam because I'm still very confused on that one.
Oh, where is it?
I'll show you after we're done here, but the
Well, let me see if I
2019
can.
IB exam was kind of whack.
Let me see if I can pull it up, though. Let me see if I can.
I might
pull
just
it
see
up.
if I can just Google it and find it, because I'm sure someone's posted it somewhere.
I
The
mean,
meal
someone
strat.
posted an explanation. They
Well,
kind of
what the heck? It's
skirt
not-
over how they get one of the values, and that's what I'm confused.
Why is it not showing up in my thing? What the hell? This is weird.
Go to results.
I did go to results. It's not there.
Huh? It's not there anymore.
It's not there. What the heck?
What?
Hold up. I
Damn.
might
Oh,
Why-
wait.
shot.
No,
Hopefully,
never mind.
is there?
Nope.
It's
I
been
was
locked.
looking at the one from today. Oh, it's
It
locked.
said-
It's submitted. That's what it says.
It's gone.
Submitted.
It's
That's so good.
gone. It literally
So-
just deleted.
Damn, where are you? Your camera's on.
Oh, yo, it's my backup. It's my backup.
Yo, Hazel. Hazel, help! How do you do this? Oh, big cat.
Not
yawn.
one yawn.
All right, so I'm assuming the consensus is you guys can't find it.
Let me
Uh,
see. I'm looking up real quick to see if I can
It,
find it.
Alan,
it's called the
recite it from memory.
2017 International Practice Exam, and it was stupid, and I didn't like it.
Let me look that up.
I have it in my search history. I might have just searched it up. Hold up.
Yeah, I feel like all the other FAQs are fine, and then we get these 2017 International Practice Exam FAQs, like the one you over today and like the other one. I'm like, they just feel different. Like they feel distinct.
I mean, yeah, there are definitely just outliers sometimes, and that's just kind of how it is. Usually they're not
Yeah.
on the exam though,
I
because
thought
they
maybe I thought maybe what it was that we've been literally all our physics curriculum has been is just two-dimensional motion, right? Like we haven't had waves or circuits. So our conception of physics is literally just motion, right?
I mean,
And I figured
I can tell
they-
you, I looked at this problem and said, "What the hell?" Like,
I'm still waiting. I want to see this.
I'm trying to find it, but because it's the international one, I keep coming up with the ones that aren't the international one.
Is it in French?
Trying to find it.
I clicked on the link in my search history, but it's just endlessly loading. Probably because it's
Let me see if I
locked.
look up oil along with it. It'll work.
Also, the other thing you have to remember is that the questions, the FRQs on AP Question Bank, or AP Classroom rather, aren't tested. Like they're literally just ones that are basically made and then checked by like another person and then they're uploaded. Whereas the ones on the exam are actually tested with people. So you're not gonna get the like outliers on the exam that you're seeing on AP Classroom.
It keeps
So
coming
can
up
Oh
with.
yeah, I have a question because the thing is, AP class Albert. I was wondering if like the thing is like Albert, I'm better. It's like because it instantly gives me feedback. I'm more incentivized to do it better and more, I guess, than AP Classroom just isn't like I don't know. It's not my vibe, but at the same time, I was worried if Albert's questions are too different from the actual exam that I should use AP Classroom.
They're not. I mean, Alberts are openly harder, but they're not that much harder.
Well, like, are they different? Like the way they work.
No,
Are they different?
as far as the wording and the style of question, they're the same.
All right, that's cool. So they're just harder, but they don't make you like think any differently. They just make you think harder.
Correct. Yeah.
All right, that's cool. That's cool.
Yeah.
I like that.
And then Albert's FRQs are actually like really trash. Don't look at Albert's FRQs.
I will
You
not.
use AP Classroom or any of the ones we've given you. But yeah, don't use.
Looking at
Albert's
Albert
FRQs.
FRQs real quick. Be right back.
I mean, at least for physics. The ones for like history and the other classes, those are fine. The
Yeah, I
physics
like those ones
FRQs are
because I can
literal
just check the
trash.
box. I just check the box and it gives me 100, even if I didn't do it.
So okay, so to summarize the problem, it was they held some sort of like steel ball or something, a ball of mass m, over a viscous fluid, and would let go of it at different and let go of it and track the change in kinetic energy, or to change in mechanical. It did mechanical and kinetic energy as it fell down. And then they plotted a graph of change in mechanical energy versus, I think they called it like stiffness or something.
Yeah, stiffness.
To show
and
how
don't
much it
forget
slows
about
it down.
temperature.
Yes, stiffness.
They chuck
Not
temperature in there
viscosity,
for no
but
reason.
stiffness.
Yeah,
Well,
yeah.
temperature makes
It's
sense.
food.
No, temperature
makes sense.
temperature makes sense. But then
Because
they
the change in mechanical energy is equal to the change in thermal energy.
Yeah.
But anyway.
So the first question they ask is, why did the change in mechanical energy never reach the total energy of the system? Which is because it doesn't ever actually hit the ground, because they
Okay.
stop it just before every single time. Then it asks something like, God, I don't remember the question after that.
The next question was how was derive an equation for the energy lost, which wasn't actually that bad because essentially it would lose gravitational potential energy, so the equation was literally just mgd.
Yeah.
But then the next one was like, oh yeah, if you were gonna relate it to time or something, use the equation time equals cs squared. Is that plausible?
Yeah, no. Then it asked two questions with like fucking garbage formulas and said, "Does this make sense?" And no, it did two equations. Then they made sure to state that the constants have they
Units.
always have correct units. so that you can't
That's
you
it.
can't say that the units are wrong as an answer. And so it was about proportionality, and the second was about proportionality. The first one was not proportionality. I remember this. It was it was like it puts
It was
time on
Z.
the bottom instead of on the top or something like that of a fraction.
Yeah,
I
it was
mean,
time
so
equals
far
Z.
it does not sound that hard. Maybe it's I
No,
haven't
it's
actually seen
literally
the
it's just
FRQ.
weird, man. It just can't
It's
But
like
hard.
you look at it and you
but
go, "What the hell am I looking at?"
right,
It
but
was
the
like
way
it was
the
like
way that you're
scientists
describing
developing
it,
oil.
the
Why do
way
I
that you're
care about
describing it
science?
is, I mean, I agree with you. Why do you care about oil, right? But the way that you're describing the question sounds like it's literally this.
It's energy. Dr. Florence said the point was that that with the because of the oil thing, it basically eliminates everything that you can use except for energy. It's basically forcing you to use energy, is what he said.
Yeah, but the equation part, it looks like it's literally like similar to this question
Oh
from our
no,
test.
they were like incredibly stupid equations.
Hold on, let me see if I can find it.
Like they were like, bruh.
It was
It was
time
bad.
equals ds squared.
Right, but
S
I
was
mean,
the closeness.
if the question was, do these equations make sense? I am failing to see how that's
Oh,
like
do these
contained.
questions make sense? And state 2 reasons why.
I mean, I think it just
And they
wanted
were
you to talk
so
about
shit you couldn't even
proportionalities,
begin to
though.
say why they were wrong, bruh.
I mean, again, I'm not seeing the equation, so maybe it's just because I'm not seeing the FRQ. But it sounds like all you had to do was look for proportionalities and find 2 of them. I mean, and maybe it's just because I haven't seen it, because everyone in here is saying it's bad. But the way you're describing it, at least, does not sound bad.
Oh, my bad.
Oh,
It was actually 2 times the time times zs squared. I remember now. So they basically made it seem like the kinetic energy formula or whatever. And it was dumb.
yeah, it was 2 times. Yeah, it was just they were using like it was you stare at the problem and you say, I know this equation is wrong because it doesn't make any goddamn sense. But why?
Well, I wish I could put that as an answer. Like literally just like
If I remember correctly, it was because it didn't take anything about kinetic energy into account. It was just like 2x. It didn't have an m in it.
I should have just written whose ass did you pull this out of?
Yeah, no, it was
I mean, it sounds like it's not a question you're gonna get on
no way you're
on the
gonna get that in an exam.
but
Thank God, because that literally threw me off so hard. I couldn't even think about like the pumpkin question. All right, the pumpkin question.
Do you guys have the pumpkin questions on the? Or was...
Actually, I know exactly what the pumpkin question said, so I can just.
You read it. You read it so many times. You just have it burned into your memory.
If I close my eyes, I
found
can
the
still see the
questions.
pumpkin question.
I
know
found
you-
Yo!
oh, nice.
Okay, I'll send it to you guys. 1 second.
He has geolocated the question with his Allen instincts.
I don't know. I have
Let me
Allen
see. This is
instincts.
2017. Okay. There's the MCQ is also here.
Whoa, what back alleys of the internet did you go to, bro?
Oh, what's the
Upload
IB for
here.
this question?
1 second.
Pain and suffering. That's what it is.
Extracting.
Okay, CPF nerd.
Extracting, bro. Did you get a zip file?
Yeah.
Torrenting the physics
Assignments,
question.
man.
Anyway,
Oh wait, no, that's
Let
2018.
me tell you about the
Wrong
pumpkin
one.
question.
Wrong one.
Yeah.
Use the pumpkin question. Alright,
he just deleted it. I'm very
Wrong one.
confused.
I had the wrong one.
Okay.
let me tell you the pumpkin question, alright? It's
There you
Go
go.
ahead.
arrow. Alright, well, let's see what this question. Here.
We never even had to ask Dr. Floyd to go over them. We could have just looked at the one.
No, Florence went over the oil one. It was just weird.
All right. What,
No, I'm talking
what
about like the
question-
MCQ.
What question is it exactly?
I think it was like question 2 or 3 or something like that.
It was question 3 on the FRQ.
That's the answers.
Is this it? That's pumpkin. Yeah, there it is. No,
There
no,
it
go
is.
back down. Go back down. Go down.
Go down.
So slowly. So that
There
one.
it is.
That one.
There it
All right. All right. Yeah. Also, anyone who wants to leave can leave because it's like 7:31. But food
Sticky
scientists
gel. Those
have
were the
created.
words that threw me.
Let me read it. God dang it. Food science. Room temperature, the oil is a liquid. As the oil gets colder, however, it thickens into a sticky gel. To explore the properties of the oil.
Bro, I completely forgot about the rod. What's the rod doing there?
as a quantity proportional to the force required to move a rod through the oil at a standard constant speed. Alright, as a function of stiffness for the calculated data points. Alright, give a physical reason why the curve in the graph would not reach the vertical elost axis. Wait, what was elost graph? Or Emacs.
Nathan, can you read the
Yeah.
bottom left corner of the page? The bottom left corner.
What?
Read the bottom left corner of the page.
Justify your
Everyone.
answer?
No. Scroll down.
I mean, oh well.
Whip.
Yo, you should pull
Uh-oh.
up the two. Wait, when did
You
you guys
think-
take physics?
You think?
I'm reporting you to the IB.
Do you
Well,
think I
first
care?
FBI, not the IB.
Did you take it in 2018?
We took it in
This is
2019.
27, bro.
I'm gonna look at that one.
Alan, pull up the 19 one.
2019.
I mean,
there's
we already
no
put
2019.
every single FRQ
There is
from
no
our test
2019.
in review
Someone's
session.
going to
Oh my.
You know, it's not
There's
this
nothing
question was
past
like hard.
18.
It was just like, what the hell am I looking at?
Yeah.
I
so,
vote we send Nathan to jail because he made me learn how to do graph questions.
yeah,
Why
so
would you send us to
what-
jail for that? That's gonna
Go to
get you
jail.
like 20 points in the exam,
Go to
single-handedly.
jail.
Wait, what?
Like the
Yeah.
graph questions.
I mean, like
Wait, no.
part A
because-
is. Yeah, I mean,
A
A
is
is basically the initial mechanical energy that you start with is the same each time, so you can't lose more mechanical energy than you have. I mean, that's the short answer for part A. I mean, you can write
Yeah,
it out.
yeah, you can. You lose it to the You lose it.
No, I
Mechanical
think
energy
it's
losses
what
is to heat.
lost all of
How
it.
can you possibly lose more mechanical energy than you have, Alan?
Well, no, it never reaches the maximum.
Right, so that's why. Because you always start with the same mechanical energy.
Oh, but it's asymptotic, so.
I mean, I can look at what the answer says. I mean, maybe I'm just stupid and wrong, but
Literally all the answers are here. Everything is.
You're going to jail.
alright. What is it?
Zero stiffness.
Hey, that's what I got. Let's go. Cause it's talking about the vertical axis. That's the y-axis, bro.
Man, what the?
Wait, hold on. What
Huh?
did it? Hold up. What was the question? Did I read the question wrong?
No,
Yeah,
you
it's like
just the
it's
number.
like why can the
graph
curve never
will
reach
not
the vertical?
the vertical axis.
Oh,
Oh.
I misread the question as
I
well.
read that. Yeah, me and Alan both
Wait,
read the
what
question wrong.
vertical?
So no, yeah.
Because
It's,
it would
it's
have to be.
So it's asking why are there no data points over here? That's a dumb question.
That's an incredibly stupid question.
So me and Alan both interpreted it as why do the points never go above Emax?
Because that's a good question. That makes sense. No, this is just if you cool it too hard, it becomes a fucking rock and nothing falls through it.
No, it's actually the way around. If you warm it.
Bruh, what the hell?
It becomes a liquid.
and
All right.
then-
Okay, so question A, that's just dumb. All right. Part B. As S, what's S increase? F is stiffness. E loss approaches a maximum level of Emax in the graph. Write equation for Emax in terms of MD and physical constants. All right, what's M?
Mass of the ball.
Mass D.
This is just total mechanical energy.
Yeah. It
Yeah,
would
this
just
is
be
just MGD.
potential energy, MGD. Yeah.
It-
So
it's-
that's easy light work.
But no, let's get to part C, bro. Part C.
Yeah.
One of the scientists in trying. Listen, I didn't think it was a verb when you were describing it. Let me see. Although part A was actually genuinely retarded. So
Hey, I think
my
I-
opinion slowly
wait.
changes. So slowly changing. One of the scientists in trying to represent the relationship between the oil and stiffness and the mechanical energy lost writes down the equation: the energy loss is equal to C(S squared), where C is a constant, and S, I'm assuming, is stiffness. Yeah. Give 2 reasons why the equation cannot be correct. All right, so it is saying one reason, I guess, could be. Does this look like it's going to 0? Okay, well, that doesn't change anything. S squared would be the inverse graph. So this is a square root graph. The proportionality between Emax and stiffness is square root, so you can't be squared. So that's reason 1. Reason 2, though. I mean, I guess you could say because it has a horizontal asymptote, although that's secretly the same answer as the first one.
There
Wait,
isn't.
can,
I know what the answer is.
can you check the answer key, see what they said?
I can give you one reason. Two's a bit sus.
It's because
Yeah,
it
you
doesn't
literally just
take in
download
energy
the
anywhere in the
question.
question. It never actually asks about energy. It's just stiffness. And so the nothing you can do can change the result of the question.
This question sucks.
Question is so ass, bro.
I hate this
Technically,
crap.
Alan, technically both of mine would have gotten 2 points. I just
That's
wanna point
fucking
that out.
stupid.
Uh,
You said
so-
the same goddamn thing.
Hey, listen. The points. Listen, this is what I mean about AP. You gotta look at the points. The first point was 1 point for each valid independent statement that the equation does not match the graph. Okay, so that's my square root one, and then my second one, which is about a horizontal asymptote,
Bruh,
says energy
that's
loss
so
cannot increase
dumb.
indefinitely. So literally, my 2 points got all the points are perfect.
That's
All right,
you
so
said the
far-
same thing twice.
So far,
Then
I
what
have only
Same
missed.
goddamn thing.
So far, I have only missed part A because I didn't read the question right. All right, so
Shut
far
up.
I'm only at part A wrong. All right, let's now part D. Part D.
You should probably just
You
like
said it.
screenshot. Then
Hold up, is
no, it's past it.
Hmm.
Oh yeah, that's literally the one.
Hmm.
That one we did.
Nice.
That's the thing. It was like, oh, that one's easy, and then it's literally like oil.
Nice job. I mean, if you think about it, we just helped you. We just helped you there. That's all we did.
Yes, thank you with that.
Yeah.
All right. Further attempting to model the ball's motion, the scientists write the following equation for the time t the ball takes to fall through the oil. T is equal to z over s, where z is a constant with appropriate units. Is this equation plausible? All right, so this is saying that as stiffness increases, it takes less time. So no, it's not plausible because of what I just said. It's saying that as stiffness increases, it takes less time to fall through the oil, which is not true. It should take more time. All right, what's the answer?
Oh come on, you know I don't think like that. And, like
I'm just saying the question you guys are saying is like, okay, part A was retarded. I agree with that. The rest of them did not seem that bad.
oh, but
All right.
you're
1 point.
hungry,
1 point.
And 2
I mean,
points, yeah.
and they talk about sticky gel in physics.
All right. Hold on. Last one. Part.
The
I don't
last
know.
one is not that hard.
All right. Oh, is it just draw a
Yeah,
graph?
that one's easy.
All right.
It's literally
Well,
just the
I mean,
rough.
to my point, besides A being like really, it should have. An interesting question would have been why is there an Emax, but
Yeah, no,
I guess-
it should have been like that.
why they
What- but
asked
it
us
wasn't,
why it
because
doesn't reach the vertical
stiffness.
axis is beyond me. Although I guess it proves the point that I always say: make sure you read the question. That's what
Yeah.
happens when you don't.
Given that I also messed it up.
Hey, other than that, though, I mean, my point still stands. I don't think it was that bad. It's weird. I don't disagree with
Oh,
that.
we can go down to
but it-
pumpkin now, which I think is also on here.
Yeah.
All right. An archer tests various arrowheads shooting at arrows at a pumpkin suspended from a tree. When struck head on by the arrow, pumpkin swings.
He essentially said it was transferring of momentum, so velocity would be greater.
Yeah.
But it was like
The thing
Uh,
that really
I
made me
mean-
mad is between the bounce arrow and it was the thing is you'd want to say, oh, it's collisions. No, you don't actually want to do that because you can't just say elastic, inelastic, completely inelastic. That's not the answer.
yeah. He said to just think about it as transfer of momentum. Because I was trying to think about it as a collision, and then I was trying to figure out what the hell the pass arrow was supposed to be in
Yeah, no.
terms of collisions.
Yeah, no,
I was like,
I'll tell you,
Just
it
race
isn't.
through the object. What's that like? Not elastic, not inelastic. It's just
So hold on.
Thick.
So should it? I mean, I'm not thinking about this too hard, so I make this wrong. But is bounce arrow first, as in like the greatest, or am I retarded?
No.
I believe it was bounce and then
Really, it bounces
and then-
first?
Well, I mean, if you think about it in terms of energy, it should be because in bounce
Yeah,
arrow,
but it
no
bounces
energy's lost.
backwards. It has
It doesn't
less.
matter. No energy's lost. No
energy
energy's
at
lost.
all, because people kept using conservation of energy and he got mad.
I know. I mean, I know you can't use that for pass. Obviously, you can't. But like in terms of embedded versus bounce, you can rank those two in relation to each other.
Right, but it
And
bounces.
you, those,
It bounces
Okay, seriously,
back.
what was pass though? Like that one just like
It's
just
just
like-
not a collision. It's just not.
it's
I
not
mean-
a-
Hey yo, you've ever seen the movie Brave, Tehan?
Look, Unless, I mean, I just initial
Yeah.
guess. I'm not thinking about it too hard, but initial guess, I would think bounce embedded pass. Let's see what the answer says.
No, Ellie, Brave literally
The thing
carried
I
you
thought about that too,
top
but I was like, well, it's bouncing off, so therefore it must be.
Pixels of
Bounce embedded pass. Let's go.
God, dude, I looked at it and I was like, well,
Nathan,
it can't be bounce because because there's energy that's going the other way for the kinetic energy.
But it
there.
doesn't matter. It doesn't matter, Alan. Energy's not lost in that one. Whereas energy is lost because it's totally inelastic if it is embedded.
Well, right, but there's also, but it says it bounces back,
So what
meaning
he
that
said
there must
was
be
that,
energy.
like-
It doesn't. It doesn't matter though. Energy's not
Well, yeah,
lost.
yeah.
What he said was that because the bounce makes like the velocity go in a completely other direction, it like the arrow experienced like the greatest change in velocity, so that means it transferred its like velocity with its momentum into the pumpkin.
And the way that he explained it is probably like the best way to explain it, or the most accurate way to explain it. The way I would have explained it is the way that it would have made him mad, which is energy though, because like bounce, no energy's lost. Embedded, the maximum amount of energy is lost because it's totally inelastic. And pass, there's like next to no energy transfer. So that's how I would have. That's how I got that in like half.
That's how I started
And
looking
this,
at it, and
this
then
is
I
the
second
this
guessed
is the
myself.
paragraph length.
Wait, bounce is the most energy lost?
Bounce is
No,
the least energy lost.
bounce is 0 energy lost.
Yeah.
But it's only
Heck,
split
I mean,
half
that
and
is
half.
perfectly elastic, but
It bounces though.
so it's relatively what?
If it bounces, it's elastic.
If it bounces, it has to be elastic. There's no, remember, there is no perfectly elastic. It is elastic, and then it's inelastic and perfectly inelastic. There is no perfectly elastic. If it's elastic, it's elastic. That's that. There are only three ways to go. If you're not elastic, you are inelastic, and then all the way at the end of inelastic is perfectly inelastic.
Which is when they stick together.
Oh wait, so inelastic is when they
look.
keep going in the same direction, but they're just kind of
Look here. Let me show you this. This might make it easy. All right. Ignore the fact that this is Mr. Gonzalez's face. That's irrelevant. All right. Let's get that out of here. All right. So basically, imagine this is the spectrum of collisions, right? All right. So
Why was
over
Mr.
here.
Gonzalez in MS Paint?
Don't question it.
He was
Okay,
having-
I'm gonna go
What is
back,
he
guys.
doing in there?
He's
Yeah.
vibing.
If anyone needs to leave, go ahead. So you have elastic over there, and then you have perfectly.
Pew.
If
You know what? I don't care.
Pew.
like,
All right, and then in the middle, like basically being anywhere that's not elastic and not perfectly inelastic is inelastic. So that like this is one end, this is the other end. The rest is considered inelastic.
Okay, so elastic means they bounce off in different directions. Perfectly inelastic means they go together in the same direction. And then if they aren't bouncing off in opposite directions, then they aren't perfectly elastic. So if they bounce off in opposite directions, then they are.
So
Elastic.
inelastic essentially means that they intersect to some degree. Either, for example, one of the objects deforms, or some of the mass from one of the object goes into the other object. Anything like that would be considered inelastic. Whereas perfectly inelastic is the entire mass goes into the other object. Elastic is when the objects bounce off of each other and there is no energy loss. So there's no deformation, there's no heat energy loss, anything like that.
it's like pool balls colliding.
Huh.
Which is what it says. I'm pretty sure, right? It says.
Nah, it just says it like you
It
said,
bounces
like
off.
I mean, okay, so I guess technically this could be inelastic. However, it is more elastic than embedded. So because embedded is perfectly inelastic, so it doesn't matter.
Well, the
if
whole
have-
thing is that
Fine.
it's the energy of the system stays the same, but the energy in part of the pumpkin I thought would be less.
Now, to be fair, I want to make this clear. The this whole thing that I'm just drawing because we were talking about it. I don't actually think that that's how you should solve the problem. I think what Dr. Florence was saying is better, which is about energy transfer. But I probably would not have thought about that if that was on this test. I would have solved it the other way, which I am fairly certain is still correct. Let's go to the answers.
You stop streaming.
alright.
So you had to talk about momentum, but you would still get at the very least 3 points for referring it to energy. and also this point over here. But yeah, so you had to for the first 3 points you had to talk about momentum. So I guess that's fair. But
For an explicit or implicit correct justification in terms of energy conservation that the angle reached by the pumpkin is related to the speed of the pumpkin just after the collision. All right.
Yeah, that's just 1/2 mv squared equals mgh.
All right. All right. Well, that all makes sense. I have to go now. So
All right, yep.
I'll see you guys tomorrow.
Yep. See
Yeah,
y'all
so
tomorrow.
do I. Thank you.